Ever since we started building cities, we've had this deep-seated fear of the ground just shaking beneath our feet. And for geologists, the holy grail, the ultimate prize, has always been figuring out how to predict earthquakes. But what if the biggest clue we've been searching for isn't in the tremors at all? What if it's an invisible gas just leaking from the earth? So let's just get right to it. The biggest question of all, can we actually predict earthquakes? And, well, the simple answer right now is a pretty firm no. Now, don't get me wrong, we have amazing systems that can detect a quake the second it starts, that can give people a few seconds, maybe a minute to take cover. But real, true prediction, knowing days or even weeks ahead of time, that's always been just out of reach, a scientific impossibility, really. I mean, just think about it. Deep beneath us, the Earth's tectonic plates are in this constant, grinding, slow-motion collision. And when all that built-up pressure finally lets go, bam! The results can be absolutely catastrophic. And the worst part? It happens with almost no warning. It's that sheer unpredictability that makes earthquakes so terrifying, right? And it's exactly what drives scientists crazy trying to find any reliable sign of what's coming. Okay, so if we can't predict the rock itself, maybe we're looking in the wrong place. What if we looked at the air instead? Specifically at this mysterious gas that just kind of seeps up from the ground. Now, you might have heard of radon before, maybe in the context of testing your basement for home safety. But geologists, they're looking at it in a completely different light. So what exactly is radon? Well, it's a completely natural radioactive gas. It's basically born from the slow decay of other elements, like uranium, that are just naturally present in rocks and soil all over the planet. It's not some weird foreign substance. It's a fundamental part of our world's geology. And here's what makes radon so interesting for this kind of work. It has some really unique properties. For one, it's basically a ghost. You can't see it, you can't smell it, you can't taste it. But, and this is crucial for scientists, it decays pretty slowly. It has what's called a long half-life, which just means it sticks around long enough for us to actually measure it. And since you can find it pretty much everywhere in the Earth's crust, it's like the perfect undercover agent for tracking what's happening deep underground. So, all this leads us to the big idea, the central hypothesis. Could this ghost gas, this stuff that's constantly being produced inside the Earth, actually be an early warning system? Could the amount of it we're seeing tell us something about the incredible stress that's building up deep, deep underground? Okay, so here's the theory in a nutshell. Imagine the rock deep in the Earth's crust is kind of like a giant sponge, and it's holding on to all this radon gas. Now, as the tectonic plates start grinding against each other, building up all that stress, it doesn't just, build up to one big snap. Before that happens, the pressure creates thousands of tiny little micro cracks in the rock, opening up a brand new pathways for all that trapped gas to escape to the surface. And this diagram really shows you what's going on perfectly. So down here, you've got the active fault line. As that stress starts building up before a quake, it creates all these little micro cracks. Think of them like tiny vents. And those vents allow the radon, that's the Rn you see there, to bubble up and escape to the surface. And that's where we, hopefully, can detect it. Right. That is a fantastic theory. It makes a lot of sense. But is there any actual proof? Does it happen in the real world? Well, to find out, scientists had to get out of the lab and go to a place where the Earth is pretty much constantly on the move. They had to go and listen for this ghostly whisper coming up from the ground. And that destination was the Gulf of Corinth in Greece. It's one of the most seismically active regions in all of Europe. Basically, it was the perfect natural laboratory to set up their monitoring equipment and just watch. They watched the radon levels day in, day out, for years. And what did they find? Something pretty remarkable. I'm going to quote the research team directly here because it's just so powerful. They said, quote, "The major changes in radon level begin before the rock rupture, i.e. before the earthquake occurs." Let me say that again. Before the earthquake. This wasn't just some random correlation. They were seeing a clear, measurable signal before the big event. But they also discovered another critical detail. It turned out the best, clearest signals were coming from monitors they'd placed near hot springs. So why there? Well, it seems that deep groundwater, which gets heated up by the Earth, acts like a super-fast elevator. It shoots up through all those new microcracks, carrying the radon along for the ride, and delivers a much stronger, much clearer signal right to the surface. Okay, I know this chart looks super complex, but stick with me because what it shows is incredible. That black line, that's the actual radon levels they measured over thousands of days. Now the red line, that's what their computer models predicted the radon levels would be based on all the seismic stress. Just look at how closely those two lines match up. This is the proof. It shows that these fluctuations aren't just random noise. They are a measurable pattern, and they're directly linked to the forces that cause earthquakes. So, when you put all of this evidence together, from the initial theory to the hard data from the field, it really points to an exciting new frontier. So what does this all mean for the future of predicting earthquakes? And that brings us to the million-dollar question, the one you're probably thinking right now. Is this it? Have we finally found the secret? Is monitoring radon our crystal ball for seeing into the Earth's future? Well, let's not get ahead of ourselves. It's not quite a crystal ball. But here's what we absolutely know for sure. 1, radon levels can and do change before earthquakes. 2, we have a really solid scientific theory that links these changes to the physical stress building up in the rocks. And 3, and this is maybe the most important part, this is a super promising field that scientists are actively researching right now. So at the end of the day, while we can't circle a date on the calendar just by watching radon levels, not yet anyway, this represents one of the most promising clues, one of the most promising precursors we have ever studied. You can just imagine it, right? One day, a whole network of these detectors all around the world, constantly listening for those whispers from deep inside the Earth, they could become a crucial part of a real global earthquake warning system. And that would give us the most invaluable gift of all, the gift of time.